All right, guys, now let's talk about how to multiply radicals. Multiplying radicals is significantly easier than adding and subtracting them. It is exactly what you would expect. So let's say we did radical 3 times radical 2. That is, in fact, radical 6. That's all it is. This is actually where, though, we are going to get into some of the theory behind why radicals can simplify. So let's start with this. Let's go with radical 2 times radical 2. Radical 2 times radical 2 is radical 4. But hopefully you remember from creating all of these charts, the radical 4 is in fact 2. Square root of 4 is 2. So what this implies, and hopefully this won't be confusing here, what this implies is that radical 2 times radical 2, well, we can actually write that as radical 2 squared. So radical 2 squared equals radical 4, which equals 2. What's happening here is that the radical and the squared operation, squaring the operation, these actually cancel one another out. These are inverse operations. When these two are put together, they cancel each other out, and all you are left with is what's inside the radicand. You're left with the radicand. So the same thing is true here. Radical 3 squared, well, that's 3. Radical 4 squared, well, that's 4. And if you don't believe me, go ahead and try it. Radical 3 times radical 3 is radical 9. The square root of 9 is 3. We're left with the radicand. This can happen with pretty much anything. So let's say we have radical 7 squared. Well, that's 7. If you are confused by this, you can see it this way. Radical 7 squared is, radical 7 squared is radical 49. Radical 49 breaks down into 7 and 7, which we would circle and bring out. The reason we're able to do that is because of this piece right here. Whenever we have a pair of radicals being multiplied by each other, if they have like radicands, it causes them to no longer be operated on by a radical. And feel free to experiment with your calculator if you're curious about this. That's how it works. Now, we're going to do a video next that's going to look at some things like this. Radical x squared, well, hopefully you see that's just x. Radical x y squared, well, that's x y. However, there's some weird things with that we're going to get into later. The last thing I want to show you is if we do something like this, radical 2 to the, that's a terrible one. What am I doing? Radical, here it is. The last thing we're going to talk about here is if we have something like 2 radical 3 squared. Well, this gets a little more interesting. What this means is I first have to square 4, and hopefully you remember from your exponent rules, we also have to square radical 3. So what this says is 2 squared times radical 3 squared. Well, 2 squared is 4. Radical 3 squared is 3. That gives me 12. What if we had 4 radical 5 squared? Nope. 4 radical 5 squared. Well, that's 4 squared times radical 5 squared, which gives me 16 times 5. 16 times 5 is going to give me 80. One more just so you can see. We'll do 1 radical 15 squared. Well, that's distributing this. 1 squared times radical 15 squared. Oh, it's 1 times 15, which gives me